Welcome to Hartman Math. This is lesson 8.3, Geometric Sequences. Let's take a look at our sequence, see if we can figure out the pattern. I don't think it's adding the same thing every time, because this would be adding 8, but that's not adding 8. So maybe it's a different operation. It could be multiplication. Multiply by 3, multiply by 3. So we've seen the pattern, it's to multiply by 3. So if we're multiplying by the same number repeatedly, that's what gives us a geometric sequence. And the number that we're multiplying by, that's the common ratio, and we use the letter R to represent the common ratio. It can be found by taking any term and dividing by the one in front of it. It has to go in that order. So we could do 108 divided by 36. So we could take the second term, divide by the first. We could take the third term, divide by the second. So any one and divide by the previous one. All right, so what are our terms? We've got our first term is a sub 1. To get our second term, we take the first term and we multiply by r, the common ratio. So the second term is going to be the first term times the common ratio. About the third term. The third term would be the one right before it multiplied by the common ratio. That's essentially the definition, is we just keep multiplying by r. So it's the one right before it multiplied by r. But if we look at a sub 2, we could replace a sub 2 with a sub 1 times r. So this becomes a sub 1 times r times another r. And r times r is r squared. What about the fourth term? That would be the one before the fourth term times r. And a sub 3 is right here. And if we multiply r squared by another r, we're going to get r cubed. Fifth term, we can kind of see the pattern, is a sub 1 r times r to the fourth power. So in general, a sub n is a sub 1 times r to a certain power. Now let's see if we can connect the exponent to the subscript, the exponent to the position. How does this exponent relate to that position? This one relate to that. The exponent is 1 less than the position. Our position is n, so it's a sub 1 times r to the n minus 1. That's the formula for geometric sequences. Example 1, find a sub 12. Let's see if we can figure out the pattern. It's not adding 7. It's multiplying by 2. So it's geometric. So to find a sub 12, we're going to use the a sub n geometric formula. A sub 1 is 7. R is the pattern. It's going to be 2. Remember, we can take any number, divide by the one before it. 28 divided by 14, as long as it's geometric, is 2. So that's going to go there. And our exponent is going to be the n minus 1. So we're going to do this on the calculator. You want to simplify this part before you get to your calculator. So we're talking about 7 times 2 to the 11th. Don't do 7 times 2 and get a number and then raise. 7 times 2 to the 11th on your calculator, and you get the 12th term. And you can see with geometric sequences, the numbers get kind of big pretty fast. Because we're talking about multiplying, it gets big fast. All right, how about the U-try? Here's our sequence. Find the 9th term. Don't round off. Pause here. Go ahead and pause until you have an answer. All right, I believe this is geometric. We could test it by doing this divided by this, this divided by this divided by this. If we get the same thing every time, we know that it's geometric. And we do, and that common ratio is 0.8. So the ninth term is going to be the first term times the common ratio to the power of 1 less than the position. So on your calculator, you would do 100 times 0.8 to the 8th power, and you should get 16.777216. As I said, it didn't say to round off, so don't. Example 2, just find the generic a sub n term. What we need is first term, we know, and the common ratio. If it's geometric, it appears to be. So we're going to take any term here, divide by the one before it. So maybe 16 divided by 24. Now your calculator would give you a decimal that goes on forever. So I don't think we want a decimal, we want an exact value. We might need to reduce that. 16 over 24 reduces, I think we could divide top and bottom by 8. We're going to get 2/3. So a sub n is the first term, 54, times the ratio, simplified, exact, to the power of n minus 1. All right, you try, find the generic a sub n term for that sequence. Resume when you're ready. This time I think our r value, 20 divided by 5 is 4. Does that make sense? Times 4, times 4, times 4. Yep, it's going to be geometric. R is 4. That's as far as we go. We do not multiply these because that's not a 4. It's a bunch of 4s. So leave it separate in this form. Example 3. We know the 6th term and we know r. Find a sub n, which essentially means for finding a sub n, we need to know a sub 1 and r. We already know r, we just don't know the a sub 1. So let's use our equation and substitute in what we know. For a sub n, we're going to use this. We're going to use the 6th term to gain some information. So the 17,496 goes there. We don't know that. 3 goes here. And if we're talking about a sub 6, then n is 6. All right, so we're talking about this being 3 to the 5th power, which I'm not sure what it is. I don't really care at this point. But since this is multiplication going on, to undo multiplication, I'm going to do division. I'm going to divide by this number. I'm going to let my calculator do that work. So a sub 1 is going to be 17,496 divided by 3 to the 5th power. Your calculator would tell you 72. You don't need to calculate and find out this number. Just do this divided by this, and you get 72. So now we just go back to the beginning. 72 goes there, 3 goes there, and that's all we need. Example 4. Remember, for a sub n, we need to know a sub 1 and r, and we know neither. We do have 2 terms. Terms are going to generate equations. So remember, we're going geometric here, assuming that we're talking about a geometric sequence. And as we saw before, back in lesson 8.1, it doesn't matter, but I do prefer to use the larger position and do that one first. So we're going to do a sub 6 first, where n is 6, and we get 31,250. Underneath that, write an equation for that one. Pause until you have it. You should have come up with a sub 3 is equal to a sub 1 r squared, because n minus 1, 3 minus 1 is 2 for our exponent. We are here. Now, it's not a system that we've done before, but our technique is going to be to divide. Because when we do a sub 1 divided by a sub 1, we're going to get 1, which essentially cancels. When we do r to the 5th divided by r squared, you remember back to lesson 5.1, our exponent properties. That's our quotient property. Keep the r, subtract the exponents, we get r cubed. Divide these numbers, and you get 125. Now, how do we undo the exponent? We take a root. What root should we take? The third root. So we're going to go third root on both sides, which means that r comes out to be 5, the cube root of 125. We're going to take that and substitute back into one of these two equations. I kind of like the bottom one's a little bit smaller. So substitute 5 for the r. 5 squared is 25. This is multiplication. Undo by division. Divide both sides by 25. We get the last piece that we need. We got a sub 1. We got r. We're ready to write our answer. A sub n is equal to 10 times 5 to the power of n minus 1. And that's it for today. I'll see you next time.